there's a bunch of black plastic right above. That is all the HVAC case. It's just an electric motor with a bunch of plastic gears.
At first glance, the idea of a plastic engine sounds like something straight out of a toy factory, not an automaker's engineering lab. But during the late 20th and early 21st centuries, several car companies became obsessed with cutting weight, improving fuel economy, and experimenting with futuristic materials. Plastic seemed like the miracle answer. It was cheap, flexible, corrosion-resistant, and easy to mold into complex shapes. Engineers began replacing traditional metal components with thermoplastics and composites, even in critical areas like intake manifolds, valve covers, and coolant housings. For a while, it worked. Cars got lighter and a bit more efficient. But when the heat, pressure, and vibration of real-world driving took over, many of these innovations melted, cracked, or warped beyond repair. What was once hailed as revolutionary quickly became embarrassing. Here are 11 cars that dared to use plastic in their engines and paid the price. Number 11. BMW i3. When BMW launched the i3, it was marketed as a vision of the future, an eco-friendly car built with cutting-edge materials. Its body was made of carbon fiber-reinforced plastic. Its structure used lightweight aluminum, and even parts of its small two-cylinder range extender engine featured thermoplastic components. BMW's goal was clear: build a car that was strong, light, and sustainable. The company's engineers believed the i3's plastic engine covers, intake components, and other auxiliary parts would reduce both weight and cost. However, the realities of long-term durability painted a different picture. Many owners found that the engine's plastic parts didn't hold up well to constant thermal cycling. Heat from the engine bay caused certain components to warp or become brittle over time. While the i3's electric motor itself was reliable, the auxiliary gasoline engine in range-extended models earned a reputation for being temperamental. BMW's commitment to sustainability was admirable, but it also showed the limits of pushing too far with lightweight plastics. Repairing these specialized components was costly, and sourcing replacements often required factory-specific parts, turning what should have been simple maintenance into a headache. The i3 remains a fascinating experiment in automotive engineering. A car that proved the future could be light and efficient, but also reminded everyone that some materials still have their limits. Number 10. Smart Fortwo. The Smart Fortwo was designed to be the ultimate city car: short, quirky, efficient, and easy to park anywhere. Daimler, the company behind Mercedes-Benz, built the Fortwo with a clear philosophy: make it as light and compact as possible. To achieve that, engineers used a unique combination of steel safety structures and plastic panels for the body. But that lightweight philosophy extended under the hood too, with the use of plastic components in the engine design. The Fortwo's tiny three-cylinder engine relied on thermoplastic intake manifolds, plastic timing covers, and even composite engine mounts. The reasoning made sense on paper. Plastic parts don't rust, they're cheaper to produce, and they reduce overall vehicle weight, improving fuel economy in a car where every pound mattered. However, the real-world results were far from ideal. Owners began reporting issues with cracking intake manifolds, warped covers, and coolant leaks developing around plastic housings. The engine ran hot in compact urban traffic, and the small engine bay didn't help with heat dissipation. Over time, constant temperature fluctuations caused the plastic to harden and lose flexibility, leading to brittleness and eventual failure. Repairing these issues was often more expensive than one would expect for such a small car. Replacement parts weren't always easy to find, and the labor required to access tightly packed components pushed repair costs high. Many mechanics even joked that the Smart Fortwo's smart design was too clever for its own good. While the Fortwo succeeded as a symbol of European urban mobility, its lightweight engineering came with compromises. The heavy reliance on plastic parts, even in the engine, proved that there's a fine line between innovation and fragility. It was efficient, yes, but when the heat got serious, the Fortwo's plastic heart often couldn't take it. Number 9. Saturn SL Series. When General Motors introduced the Saturn brand in the early 1990s, it was supposed to represent the future of American car making. Smart, efficient, and forward-thinking. The Saturn SL Series was the brand's flagship compact sedan, designed to compete with imports like the Honda Civic and Toyota Corolla. One of Saturn's boldest selling points was its use of plastic. The company proudly advertised its polymer body panels as dent-resistant and rust-proof, making them sound like a miracle material. But what many didn't realize was that Saturn's love affair with plastic went much deeper than just the exterior. Under the hood, Saturn experimented with plastic intake manifolds, valve covers, and other lightweight components to reduce manufacturing costs and overall vehicle weight. Initially, these choices worked well. The engines were reasonably efficient, and the cars offered decent performance for their class. But, as the years went on, cracks began to show, both literally and figuratively. The problem was that plastic simply didn't handle heat and stress the same way metal did. Intake manifolds made from nylon-based composites began to warp, leading to poor sealing and air leaks. Valve covers that were once praised for being lightweight started to leak oil as the plastic aged and became brittle. In colder climates, the rapid temperature swings made things even worse, with some components cracking during winter starts. Owners who once loved Saturn's low maintenance costs suddenly found themselves paying hundreds of dollars for repairs involving hard-to-find plastic engine parts. Unlike traditional metal components that could be welded or machined, plastic parts often had to be replaced entirely. Despite these issues, the Saturn SL remains an interesting chapter in automotive history. A car built with optimism and experimentation. It proved that plastic could revolutionize manufacturing, but it also served as a warning that even the most innovative materials can fail when pushed too far. Saturn's "different kind of car company" slogan was true, but sometimes being different came at a cost. Number 8. Renault Clio 56. Few cars captured the spirit of reckless engineering bravery like the Renault Clio 56. It looked like a small hatchback, but under that wide, muscular body sat a mid-mounted V6 engine. The kind of setup you'd expect from a supercar, not a commuter. Built in partnership with Tom Walkinshaw Racing, this car was wild, loud, and completely impractical. And it had more than its fair share of unusual engineering choices. Among them was Renault's use of plastic components within the engine structure, a decision that made the Clio 56 as fragile as it was fascinating. To save weight and optimize airflow, Renault used composite plastic materials for the intake manifold, throttle bodies, and several engine covers. The idea was to combine racing-inspired performance with modern manufacturing techniques. But the V6's mid-engine layout created a furnace-like environment behind the driver, with limited cooling and constant heat soak. Over time, this intense heat took a toll on the plastic parts, causing warping and micro cracks that led to performance inconsistencies and vacuum leaks. Owners began noticing idle issues, air-fuel mixture problems, and even melted components after extended high-performance driving. The same technology that made the Clio V6 lightweight also made it incredibly sensitive to heat and vibration. Replacing these parts wasn't easy either. The mid-engine setup meant that even simple repairs required major disassembly, often at enormous labor costs. Despite its flaws, the Clio V6 has since become a cult classic, loved for its insanity and character. But it also serves as a perfect example of how even brilliant ideas can be undone by one small engineering compromise. Plastic parts might have shaved off a few pounds, but they couldn't stand up to the brutal reality of a roaring V6 trapped in a tiny chassis. In the end, Renault's bold experiment produced a car that's unforgettable, both for its performance and its fragility. Number 7. Ford Taurus, 1990s. The Ford Taurus was once the pride of American family sedans. In the late 1980s and throughout the 1990s, it was one of the best-selling cars in the United States, praised for its comfort, practicality, and forward-thinking design. But behind its popularity, Ford was also experimenting with new cost-saving materials. And plastic was at the center of that plan. The Taurus became a quiet test bed for the automaker's shift toward composite components, particularly in its engine design. Starting in the mid-1990s, Ford began using plastic intake manifolds, valve covers, and thermostat housings on several of its V6 engines, including the famous 3.0-liter Vulcan and 3.8-liter Essex variants. These parts were cheaper to produce and lighter than traditional aluminum or steel. For a while, it seemed like a smart move. The engines ran smoother, fuel economy improved slightly, and manufacturing costs dropped. But after just a few years on the road, the cracks, literally, began to show. The plastic intake manifolds were prone to warping under heat and pressure, leading to coolant leaks, vacuum loss, and eventually, full-blown engine damage. Ford owners began reporting sudden loss of power, check engine lights, and coolant dripping onto the hot engine block. The thermostat housings, made of the same material, often failed in similar fashion, leading to overheating issues that could quickly spiral out of control. The problem became so widespread that Ford faced multiple recalls and even class-action lawsuits over defective plastic intake manifolds, particularly on models using the 4.6-liter V8, found in other Ford vehicles like the Crown Victoria and Mustang. The Taurus wasn't alone, but it became one of the most notorious examples of the cost-cutting trend gone wrong. In hindsight, the Taurus serves as a classic example of 1990s engineering optimism clashing with real-world durability. Ford wanted innovation and affordability. Instead, they got melted manifolds and angry owners. It was a harsh reminder that some materials, no matter how cheap or light, simply can't handle the heat of a working engine. Number 6. Peugeot 206. The Peugeot 206 was one of Europe's most popular small cars in the late 1990s and early 2000s, stylish, affordable, and fun to drive. It was France's answer to the Volkswagen Polo and Ford Fiesta, and for a while, it sold in huge numbers across Europe and Asia. But under the hood, Peugeot's engineers were quietly pushing the boundaries of lightweight engine design, and that included a heavy reliance on plastic components. To reduce costs and improve efficiency, Peugeot used plastic intake manifolds, camshaft covers, and even timing belt covers in the 206's TU and EW engine families. The move was meant to reduce overall engine weight and improve airflow, theoretically helping fuel economy and emissions. At first, the idea worked beautifully. The 206 felt peppy for its size, and owners appreciated its low running costs. But over time, the plastic parts began to reveal their darker side. The intake manifolds, made from glass-reinforced nylon, were prone to warping and cracking after years of exposure to heat cycles. The engine bay of the 206, especially in warmer climates, could reach extreme temperatures, softening the plastic and causing vacuum leaks that led to poor idling and loss of power. Things got worse as the car aged. Owners began reporting that the plastic valve covers became brittle, leading to oil leaks that dripped onto the exhaust manifold, a dangerous combination. Even the timing belt covers, which were supposed to be simple protective pieces, often warped and came loose, exposing critical engine components to dust and debris. Replacing these parts was not only frustrating, but also surprisingly costly. Genuine replacements weren't cheap, and aftermarket options rarely lasted long. Many mechanics in Europe grew to despise the Peugeot 206's plastic personality, often advising customers to replace entire assemblies rather than repair them piece by piece. Despite its reliability issues, the 206 remains an icon of French automotive design, nimble, charming, and unmistakably stylish. But it also stands as a symbol of a time when carmakers became too confident in plastic's promise. Lightweight materials made the 206 efficient, but in the long run, the heat and stress of daily driving proved that even the prettiest little car can melt under pressure. Number 5. Mercedes-Benz M272/M273 engines. When Mercedes-Benz introduced its M272 and M273 engine families in the mid-2000s, they were meant to represent a new era of engineering excellence. Powerful, smooth, and efficient V6 and V8 engines designed for everything from the E-Class to the S-Class. On paper, they were marvels of modern design, boasting variable valve timing, lightweight construction, and improved fuel efficiency. But behind the luxury badge and the polished marketing, Mercedes had quietly made a controversial decision: extensive use of plastic inside the engine. The M272 and M273 engines featured plastic intake manifolds, plastic balance shaft gears, and plastic flaps within the intake system. The goal was clear: reduce weight and improve airflow efficiency. Unfortunately, these choices would go on to haunt the brand for years. The plastic intake manifold runners were equipped with small actuator arms that adjusted airflow for performance tuning. Over time, these arms, made from brittle plastic, wore out, cracked, or snapped entirely. When they failed, the engines lost power, ran rough, and triggered the dreaded check engine light. It didn't stop there. The plastic balance shaft gears in early versions of the M272 also developed severe wear problems. As the gears degraded, timing went out of sync, leading to rattling noises, rough idling, and eventually catastrophic engine damage. Mercedes, of course, faced a wave of complaints and expensive warranty repairs. The issue became so notorious that entire forums and repair shops began specializing in fixing M272/ M273 plastic failures. Ironically, these engines were installed in some of the brand's most prestigious models, cars that carried price tags north of $60,000. Owners who bought Mercedes-Benz vehicles for their reputation of bulletproof reliability suddenly found themselves staring at repair bills that easily exceeded several $1,000s. The lesson was harsh. Even the world's most respected luxury automaker wasn't immune to the pitfalls of plastic engine parts. In hindsight, the M272 and M273 represented a turning point for Mercedes-Benz. The company eventually reverted to more durable materials in later designs, but the damage to its reputation was done. These engines remain a cautionary tale, proof that even when precision-engineered, plastic inside an engine can turn a luxury car into a long-term liability. Number 4. Toyota Celica, 7th generation. When Toyota launched the 7th generation Celica in 1999, it was aiming for a youthful, high-revving sports coupe that combined sharp design with reliability. Powered by the now famous 1.8-liter 2 ZZGE engine, co-developed with Yamaha, the Celica GTS became a lightweight marvel, capable of revving up to 8,200 RPM while maintaining Toyota's signature efficiency. But hidden within that engineering brilliance was one controversial decision: the increasing use of plastic components inside the engine bay. To keep the car light and affordable, Toyota equipped the Celica's engine with plastic intake manifolds, throttle bodies, and even several auxiliary covers and housings. The reasoning was straightforward. Plastic was cheaper to mold, lighter than aluminum, and resistant to corrosion. For the first few years, everything seemed fine. The 2 ZZGE engine was loved for its performance and screaming top end. But as these cars aged, the flaws of plastic under extreme heat and vibration began to surface. Owners began reporting cracked intake manifolds, warping around the throttle body, and coolant leaks from plastic thermostat housings. These weren't isolated incidents. In hotter climates like California, Texas, and Florida, the intense heat inside the engine bay would cause the plastic to lose structural integrity, leading to poor sealing and vacuum leaks. Many mechanics noted that once these parts failed, replacements were not only expensive, but also tricky to install due to tight engine layouts. Ironically, Toyota's reputation for durability made these failures even more frustrating for loyal owners. The metal components of the 2 ZZGE, the block, head, and internal parts, were nearly indestructible. Yet, the supporting plastic hardware often became the weak link that caused drivability issues. Despite this, the Celica remains a fan favorite, and the 2 ZZ-GE engine went on to power several other models, including the Lotus Elise. The engine's performance credentials were never in question, but its plastic elements showed that even Toyota wasn't immune to cost-saving experiments during the early 2000s. The 7th generation Celica stands today as a symbol of both engineering brilliance and material compromise. A car that could scream to redline all day long as the plastic didn't melt first. Number 3. Volkswagen Golf MK4. The Volkswagen Golf MK4, produced from the late 1990s through the early 2000s, is often remembered for its solid build quality and refined driving feel. It was marketed as a car that combined German engineering with everyday practicality. A people's car done right. But while the Golf earned a reputation for premium comfort and tight handling, it also quietly ushered in a new era of lightweight plastic components, especially in the engine bay. Volkswagen, like many manufacturers at the time, was obsessed with improving fuel efficiency and reducing production costs. As a result, the Golf MK4 came equipped with a variety of plastic engine parts: intake manifolds, valve covers, coolant flanges, and even thermostat housings. These pieces were designed to be lighter, cheaper, and more resistant to corrosion compared to metal. For a few years, everything seemed to work as intended. The Golf's engines, particularly the 1.8T turbo and 2.0-liter units, were smooth, responsive, and relatively efficient. But as the miles piled on, reality hit hard. The plastic coolant flanges, in particular, became infamous among mechanics. They were prone to cracking and leaking, often without warning. A small coolant drip could quickly turn into an overheating nightmare if left unchecked. Likewise, the plastic intake manifolds began developing leaks around gasket areas, leading to rough idling and decreased performance. The heat from the compact engine bay of the turbocharged models accelerated the aging of these materials, causing them to harden, warp, and eventually fail. What made matters worse was Volkswagen's tight engine packaging. Accessing and replacing these plastic parts was far from simple, often requiring partial disassembly of surrounding components. Many owners found themselves paying hefty labor costs just to replace a small cracked housing or warped manifold. The Golf MK4 still holds a special place in automotive history. It represented Volkswagen's move toward a more premium, modern design philosophy. But its reliance on plastic components in critical engine systems revealed the trade-offs of that transition. While the car's chassis and interior aged gracefully, its plastic heart didn't. For many longtime VW owners, the MK4 was a reminder that even German precision couldn't save a plastic part from the laws of heat and time. Number 2, BMW Mini Cooper, early 2000s. When BMW revived the Mini brand in the early 2000s, it was seen as one of the smartest comebacks in modern automotive history. The new Mini Cooper blended retro design with German engineering precision, compact, sporty, and full of character. On the surface, it looked and felt like a premium small car. But under the hood, BMW's decision to use plastic extensively in the Cooper's engine bay would prove to be one of its biggest long-term mistakes. The early R50 and R53 Mini Coopers came with engines filled with plastic components, thermostat housings, coolant expansion tanks, intake manifolds, valve covers, and even timing chain guides. BMW engineers believed these lightweight materials would help improve efficiency and reduce manufacturing costs. Unfortunately, they hadn't accounted for how poorly these plastics would age under the extreme heat of the Mini's compact engine bay. The most infamous culprit was the thermostat housing, made entirely of molded plastic. Over time, it became brittle, warped, and started leaking coolant. The leaks often went unnoticed until the engine overheated, leading to expensive repairs or complete engine failure. The plastic coolant expansion tanks were another weak link. They frequently cracked under pressure, spraying coolant across the engine bay and causing steam to pour out from under the hood. Even the plastic valve covers were a nightmare for long-term reliability. They would warp and leak oil onto the exhaust manifold, creating burning smells and occasional smoke. Some owners reported replacing the same plastic parts multiple times throughout the car's life. Mechanics often joked that the Mini Cooper should have come with a starter pack of replacement plastic parts. These issues became so common that entire aftermarket industries formed around producing aluminum replacements for the Mini's failing plastic components. Once owners replaced the fragile factory parts with metal ones, most of the car's reliability problems disappeared. Despite its flaws, the Mini Cooper remains beloved for its fun handling and personality. But it's also a textbook example of how poor material choices can ruin an otherwise brilliant design. BMW's push for modernity came with a hidden cost, a small army of cracked, warped, and melted plastic parts that turned maintenance into a recurring nightmare. For many early Mini owners, the charm of the car didn't outweigh the frustration of its fragile engine bay. Number 1. Chevrolet Malibu, late 1990s to 2000s. The Chevrolet Malibu of the late 1990s and early 2000s wasn't flashy or fast. It was built to be a dependable family car. But beneath that reputation for affordability and simplicity lurked one of the most infamous examples of plastic gone wrong in automotive history. GM's decision to use plastic intake manifolds and gaskets in the Malibu's 3100 and 3400 V6 engines would go on to haunt thousands of owners and tarnish GM's reputation for years. To cut weight and production costs, General Motors equipped these engines with upper intake manifolds made of composite plastic and rubberized plastic gaskets designed to seal coolant passages. The idea seemed sound in theory. Plastic doesn't rust. It's easy to mold, and it offers smoother airflow compared to cast metal. But under real-world conditions, with constant heat cycling, coolant pressure, and engine vibration, these plastic components quickly showed their weaknesses. Over time, the intake manifold would warp, and the gasket material would deteriorate, allowing coolant and oil to mix. This led to overheating, sludge buildup, and, in many cases, complete engine failure. The issue became so widespread that mechanics across North America knew the GM plastic manifold problem by name. The problem didn't just affect the Malibu, it plagued several GM models using the same engines, including the Impala, Grand Am, and Venture minivan. What made it worse was how quietly it happened. There were no sudden noises or warnings, just slow coolant loss, unexplained overheating, and eventually white smoke billowing from the exhaust as coolant burned in the combustion chamber. Many owners discovered the issue only after their engines were already damaged beyond repair. Lawsuits eventually followed, and GM settled multiple class action cases related to these failing plastic intake manifolds. Replacement parts with improved designs eventually appeared, but the damage to the brand's reliability image was already done. Even today, mechanics often use these Malibu engines as a cautionary tale about the dangers of mixing critical engine components with cheap plastic. The late 90s Malibu was meant to be simple and dependable, a car for the everyday American family. Instead, it became a textbook example of how one bad engineering decision can turn an otherwise solid car into a long-term liability. GM's gamble on plastic might have saved a few dollars per vehicle, but in the end, it cost them far more in reputation and customer trust. Plastic in engine design was supposed to represent the future. Lighter cars, better fuel economy, and lower emissions. And while the idea wasn't entirely wrong, the execution often was. Heat, vibration, and pressure inside an engine aren't kind to plastic, no matter how advanced the composite may be. From BMW's high-tech experiments to GM's cost-cutting missteps, each of these cars proved the same point. There are limits to how far innovation can stretch before it breaks. Today, automakers have learned to use plastics wisely, in non-critical areas or as part of reinforced composite systems that can actually handle the stress. But the legacy of these plastic engines still lingers as a reminder of a risky chapter in automotive history. In the race to save weight and money, some brands forgot that strength and longevity can't always be molded. Sometimes, the old-fashioned metal still wins,